2-dimensional case.
सर 2D में सर्कल
E2 is a big
Circle से dot sphere.
2D में circle. In 2D, it will the points will lie on this circle, right? Circle of radius r, right?
Yes sir.
Okay, so that means, does it look like a circle? So basically the point is that if you draw a circle, let's say around here, let's say this is the circle, okay? So all the points in this circle will represent that particular vector, right?
Yes sir.
Yes sir.
So that means all these lines that they have drawn here, they actually represent this vector r, right? Yeah?
Yes sir.
Yes.
And magnitude is, if you increase x and y both, then magnitude will also of this vector will also increase, right? Understood? Because if you increase x and y, then your r vector, the radius also will increase accordingly, right?
Yes
So
sir.
that means in this case, this vector, if you have to find the vector for this particular graph here, then vector will be represented by x cap plus y cap, and if it is actually 3-dimensional, if you have the z-axis as well, which is actually coming out of the page, if you include the z-axis, then it will be x cap plus y cap plus z cap, right?
Yes
Okay.
sir.
Okay. Now let us find out what is the divergence of this particular vector. It is very easy to find out the divergence, right? From the mathematical expression. So del dot VA. This is the divergence of this vector field. That will be simply del x of x, del of y, del z of z. And this will give you 3. That means you see now this is divergence of this vector field is 3, right? So it is a positive divergence, right?
Yes sir.
And positive divergence means it is actually going out of this particular point. That is what it means, positive divergence means. If this arrows were instead of going out, if it is actually coming in, what should be that? It will be positive divergence or negative divergence?
Negative divergence.
So negative.
It will be negative divergence, right? Because if all the vectors are actually coming in, then it will be actually instead of r, it will be minus r, right?
Yes sir.
Yes sir.
And if it is minus r, then del dot VA will be minus 3. Okay?
Yes sir.
Understood? Okay.
Yes sir.
Sir,
So now let me,
सर
yeah.
सर वो एक्स वाई जेड के जगह पे अगर 1/x 1/y 1/z होता तो क्या होता?
Okay, 1/x 1/y 1/z होगा तो it will not look like this one, right?
No.
Then you see, if it is 1/x 1/y 1/z, then what will be del dot that particular vector? Del x of 1/x is 1.
1/x square.
Log x.
No,
Minus
1
1 by x square.
minus 1 by
Minus 1 by x square.
Minus 1 by x
Minus
square.
1 by x square, right?
Yes
So it
sir.
will be minus 1 by x square, then minus 1 by y square, and then minus 1 by z square, right?
Yes sir.
And then you have to see at, let's say you want to find out the divergence at any point 1 1 1. Let's say xyz point is 1 1 1. Okay, so at that particular coordinate, what will be the value of divergence? It will be all minus, right?
Yes.
सर
So that is a minus negative quantity.
सर
Yeah.
और इसमें वो वेक्टर का डायरेक्शन इनवर्ड नहीं होगा ना, वेक्टर का डायरेक्शन तो आउटवर्ड ही होगा, बस उसका वेक्टर का साइज घटता जाएगा, मैग्नीट्यूड घटता जाएगा।
हाँ,
तो इसमें क्या बोलेंगे? इसको डाइवर्जेंट
1 by x means 1. As x increases, your vector is decreasing or increasing?
Decreasing.
That means your arrow also should be actually ultimately your length of these things are actually decreasing, right?
वही
So that means what? It will be actually negative divergence. It's
मतलब
not only the arrow, but also you have to look at the magnitude also.
दोनों में से किसी एक का होने से भी हो जाएगा.
हाँ, exactly. So in this for this particular case, as x, y, and z increases, r also increases, right?
Yes.
That means your magnitude also increasing along that particular direction. Understood?
Yes, sir.
So that's why it is called positive divergence. However, if it is 1 by x, 1 by y kind of thing, then what will happen? It will actually, although it will point along this direction, but your vector size of this vector will be actually magnitude of that vector is actually decreasing along that direction.
Yes,
Right? Yeah.
Sir, if it will be minus, then the arrows will be opposite, no, sir?
Which one minus?
So it means if we put 1 by x, 1 by y and 1 by z.
डाइवर्जेंस माइनस होगा ना, उसका एक्चुअल वैल्यू तो माइनस नहीं होगा ना, वो तो 1 by x.
No, this vector will be always pointing. See, this is 1 by x also means it will be the vector is pointing outward only. However, the magnitude is now decreasing. Understood?
Yes, sir. Yes, sir.
So in that sense, it will be actually negative divergence because it is diverge. Although it is diverging, but magnitude is, as you go away from this point, the magnitude is decreasing, right? As a function of x, y, z, right?
Yes, sir.
So means minus sign represents the magnitude, no, sir? Means decreasing magnitude.
This when you find out the divergence, it gives you a scalar number, right? Scalar quantity.
Yes, sir.
So if it is minus, it actually tells you about the mainly the magnitude itself.
Okay, sir.
Okay.
डायरेक्शन पे इतना डिपेंड नहीं करता वो चीज.
Direction is even if you instead of x, if it is minus x, let's say I was talking about minus r vector, that means it is minus x, minus y, minus z, right?
Yes, sir.
So that means if x increases means this will actually decrease, right? Minus means along the minus direction, minus 2 is greater than minus 1 or less than minus 1?
Less than.
Minus 2 less than minus 1.
So that is why. So in this case, if it is minus x, so if you increase x, your actually magnitude is decreasing kind of thing, right?
Decreasing. Yes, sir.
Right. So that is why actually that will be also a negative divergence, right?
Yes, sir.
Okay, clear?
Clear, sir.
Yes, sir.
Okay, now look at this figure here, this particular figure. In this case, can you tell me what is it? Means what is the divergence here? Is it zero divergence or
Zero.
Zero, sir. Yes, sir.
this is zero divergence, right? Because all the magnitudes are exactly same, right? Magnitude of the vector fields are exactly same, does not change. So that means this is actually zero divergence case, right? What about this one?
Positive divergence.
This is positive divergence because magnitude is actually increasing as you go along this particular direction. Magnitude is increasing. That's why it is called positive divergence. So mainly it depends on the actually magnitude. Okay? Clear?
Yes, sir.
Yes, sir.
Okay, now if I have to represent this one in mathematically, so let's say this is the z direction. They have actually keep saying that this is z direction. So if I have to represent this one mathematically, that will be what? Can you tell me what kind of here actually magnitude is constant, same, and it is moving along the z direction. The vector is actually along the z direction. So how do you represent this vector?
KZ cap.
Kz cap. So k is basically some constant, right?
Yes, sir.
Sir.
Yes.
Or so they have actually, instead of k z cap, they have simply written z cap, and they are saying that the magnitude is 1. It is same. Either you can write as k z cap, k also, if k is constant, if you find what is del dot vb, even if it is k z cap, then it will give you 0, right?
Yes,
Okay. So it is very clear from this particular figure itself that for this particular plot or for this particular vector function, this divergence has to be 0. And what will be the vector in this case?
Z cap.
Z cap, because along z direction the magnitude is also increasing as z increases, right? So it is represented by z cap. If you find the divergence of z cap, it will simply be 1. That means that it is actually a positive divergence case. Okay, clear everyone?
Yes, sir.
Yes, sir. Can you explain the B part, sir? KZ1.
This one.
Yes, sir.
Okay, so if you consider kz cap, k is constant, right? Because magnitude remains same. Okay.
Yes, sir.
So if you do a dot product of del dot vb, this part is anyway 0 because there is no x dependency, and z dependency is also going to be 0 because del z of k, del z of k is also 0, right?
Yes, sir.
So divergence is going to be 0, right? Mathematically also.
Yes, sir.
Clear?
Yes, sir.
Okay. So any doubt about this part?
No, sir.
Okay, fine.
No.
Okay, so divergence, there are again several problems given in this book. You can try to do few of these. It's very simple. Divergence, calculation of divergence is quite simple, right? It is basically dot product, nothing else. So now I am going to talk about curl. Curl is defined as cross product of this del operator with this vector function v, and we know how to find out actually curl or basically cross product. That is actually determinant of this particular matrix x cap, y cap, z cap. Then this del operator, for the del operator it is del x, del y, del z. For v it is vx, vy, vz. So if you find out the determinant, it will be simply look like this. So this is the curl of v. Okay. So this definition is clear, right? This is very simple. Okay. Or do you have any doubt? About this definition? No, right? Okay, fine. So now let us look at the physical meaning of this curl. Curl, what actually comes to your mind when you hear this word curl?
Sir, at what extent it can turn? It can turn, sir.
Turn, oh yeah, exactly. So curl, already you know, curl means actually it's turning kind of thing, right? Curl up. So you already have that meaning. Geometrical meaning is that the name curl is also very well chosen because curl itself tells you how much something actually rotates around a certain fixed point, right? So curl of v is a measure of how much the vector v curls around or swirls around the point in question. So how much this vector actually rotates or turns around a certain point. That is what actually geometrically it means. Fine. So now I will give you some example. So if you look at this vector here, this is xyz plane, xyz axis. Z is actually along this up direction, and xy is on this vector actually lies on the xy plane in this case, right? Okay. So if you have to find a vector for this particular plot, how do you find out the vector in this case? What is the vector? Vector is actually given by this one, minus y x cap plus x y cap. If you draw this vector in this x, y, z, there is no z direction in this case. So it is basically lying on the XY plane and it will look something like this. Can you draw this vector? You just try it, okay? In a pen and a paper, just take one pen and a paper and try to plot this vector function on the XY plane, because it lies on the XY plane, and for different values of X and Y, the vector will be actually different, right?
Yes, sir.
So that is what actually it is plotted here. So let's say, I will just give you one example. Let's say Y equal to 0 and X equal to 1. So what will be the vector at that particular point?
Y cap, sir.
Y cap. That means VA will be Y cap at X equal to 1 and Y equal to 0, right? X is 1 means this is the point, let's say X is, or let me just point, this is X equal to 1, okay? On this particular line, on the x-axis, Y equal to 0, right? Okay?
Yes, sir.
Yes, sir.
And from this point, if you have to draw down our vector V will be along which direction?
Sir, in the Y direction.
Y cap. So this is Y cap, right? This is the direction of the vector. Clear?
Yes, sir.
Understood? So at this particular point, X equal to 1, if you have to draw the vector, it will point along the Y direction. Right? So this is the vector. Is this point clear, everyone?
Yes, sir. Yes, sir.
Similarly,
Yes, sir.
now let us take Y equal to 0, X equal to minus 1. Then VA will be minus Y cap, right?
Yes, sir. Yes, sir.
And where is X equal to minus 1? This is X equal to minus 1, right?
Yes, sir.
Yes, sir.
So your vector, if you have to draw at this point, then it will be along the minus Y direction, right?
Yes, sir.
So you see, the vector itself, in one case it is along this direction, and X equal to minus 1, it is along negative direction. Similarly, you can do for the others, and you will see that the vector actually will look something like this on the X plane for different values of X and Y. Clear, everyone? You can actually draw it for few different points of X and Y, and then you will see that it automatically gives rise to this particular figure. Okay?
Yes, sir.
Okay. So now from this figure here, can you tell me what should be the curl of this particular vector?
Sir, along positive Z direction.
Along positive Z direction, right? Because it basically is nothing but the right hand rule, right? This right hand thumb rule. If you apply the right hand thumb rule, all the thumb will actually point along the Z direction, right? In this case.
Yes, sir.
Yes, sir.
And if you curl up all the other fingers along the direction of the vector, then the direction of Z will give you the direction of this curl, right?
Yes, sir.
Yes.
Okay.
Yes,
So
sir.
curl of this vector should be always pointing along the Z direction, right? From this particular figure. Now let us see mathematically whether we get along the Z direction. So for this vector function, if you find out the curl, you see that this gives you 2 into Z cap. So Z cap defines means this vector is actually along the Z direction, right? Okay?
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
similarly, there is another vector function which is VB equal to X Y cap, which is actually given by this particular figure here. If you, again, for different values of X, you can actually figure out that it will look something like this. Right? Because if X equal to 1, X equal to 2, always it will be along Y direction. So if X is positive, it will be pointing along Y direction. If X is negative, and it will be pointing along negative direction. So that is the thing, right? Clear? Okay.
Yes, sir.
So in this case, also now you see this is also actually curled up, although it actually going to infinity kind of thing. But again, there is a rotation kind of thing, right, of this factor. It is going along positive y, then it actually reverse back and going along negative direction along this. So curl of this also should be along the z direction, right? Is it clear?
So here, how will you divide the equation by seeing the graph figure?
Okay, so just look at this one. So in this case, if x is positive, right? Value of x is positive, the factor is always along the y direction, right?
Yes, sir.
That means, and if you look at the magnitude of the factor, if you increase the value of x, magnitude is increasing, right? Is it clear? Magnitude
Yes,
of the factor is actually increasing with x, right?
Yes, sir.
That means it has to be x into y cap, because y cap is the direction and x actually gives you the magnitude of this factor. So if you increase x, magnitude also increases. Here.
Yes, sir.
So that is what actually it's given. VB is actually x y cap for this particular factor. So if you find out what is the curl of this factor x y cap, you will find that it is z cap. That means it is also, the curl is also along direction, z direction here. Okay, is this clear, everyone?
Sir, it is quite similar like torque.
Yes, it is very similar to that. That's true. So curl always means how much a factor actually rotates around or curls around a certain point. In this case, it actually rotates around this particular point here, right? And here also it rotates around this particular point. Okay, clear?
Yes, sir.
सर बी पे तो टार्डिंग बहुत दूर दूर हो रहा है ना सर?
B पे
टार्डिंग elongated.
हाँ, basically in this case almost like it is infinity. It will go on.
तो सर सेंटर पे कुछ होगा क्या, मतलब सेंटर पे जेड एक्सिस फोर्स होगा क्या सर, क्योंकि इंफिनिटी की तरफ जा रहा है.
हाँ, so basically if you see if x 0, the vector is remain here, right, in this case at 0 point.
Yes sir.
So that means once you, so this is if you kind of it will look something like you see if
bowl type.
So let's say there is a pond, right?
Sir.
If you drop one stone in the still water, what will happen?
So ripples will generate. So
that also will something kind of ripple, that will not be quite good example.
In ripples center have maximum though sir.
So that is not a good example. So in this case, means once how to explain, how is there any good example for this one? I am not quite finding anything right now. But anyway, but this is also will look anyway. It goes to infinity kind of thing. But point is that it's still along. It is still rotating, right? Once this all the vectors are along this direction, then if you go along, if you look at the negative x direction, it is actually coming in this direction.
Yes.
So that means it is also kind of rotates around certain point. Although it is not exactly same as this one, but it also looks kind of that way, right?
Yes, sir.
So yeah, this example is quite this actually is quite simple to understand. If you look at even let's say right now I am not here also. Let's see if there is
सर
any
टोर्नेडो वगैरह होगा कि नहीं इसका एग्जांपल?
हाँ हो सकता है, और ये भी हो सकता है जैसे वॉशिंग मशीन।
जी सर, वो बीच वाला कम मूव करता है, बाहर वाला
वर्लपूल।
हाँ एग्जैक्टली, ये सब होगा। अभी वॉशिंग मशीन में भी तो ऐसा होता है ना, पूरा घुमाता है ना। सो इट्स समथिंग लाइक दिस वन, राइट? And this is basically large. If you look at compare these two figures, basically it is like this one is a large scale of this one. If you look at this one in a large scale, these two are almost similar case.
Yes sir, just elongated.
Exactly, almost similar, except in this case just looking at these two things, these two are very similar, like VB and VA are very similar. Only thing is that here y is 0. If you put y equal to 0, VA and VB are exactly same.
Yes sir.
Okay, so that is kind of means no, I cannot think of anything else. Means how any example I am not kind of getting any physical example, but yeah, it looks like it is also means turning around this particular point, but at a large distance, at a very very large distance. Okay.
Yes sir.
Yes, sir.
Okay, I'll see if I can find some relevant example of this one. But yeah, at this particular point, I am not finding anything. Also, you also tell me if you find something. Okay.
Okay sir, we'll start.
Yeah, you just look at it. Okay, so I'll stop it here. Yeah.
सर ऑल ओवर देखे तो ये कर्ल जो है एक्सेप्शन हो गया ग्रेडियंट और डाइवर्जेंट से।
एक्सेप्शन मींस
एक्सेप्शन मतलब सर वेक्टर ही ले रहा है तो वेक्टर ही दे रहा है, है ना सर?
एग्जैक्टली।
जबकि ग्रेडियंट वेक्टर ले रहा है तो स्केलर दे रहा है, और डाइवर्जेंट स्केलर ले रहा है तो हमको वेक्टर दे रहा है।
नहीं, तुम थोड़ा उल्टा बोल दिया। डाइवर्जेंस में वेक्टर दिया है, स्केलर मिला,
स्केलर दे रहा है, इसमें स्केलर दे रहा है, वेक्टर दे रहा है। ग्रेडियंट में डाइवर्जेंट।
तो बेसिकली ये
जी
ये देखना तुमको।
यस सर।
सर आप ये अपलोड कर देना सर।
हाँ आज ही अपलोड कर दूंगा
सर। इस पे थोड़ा क्वेश्चन भी अपलोड कर दीजिएगा।
ठीक है, मैं आज देखता हूँ क्या क्या क्वेश्चन हो सकता है, मैं अपलोड कर दूंगा
तीनों पे, ग्रेडियंट, डाइवर्जेंट और कर्ल पे। ओके सर।
एक्चुअली वी विल डू फ्यू प्रॉब्लम्स इन द ट्यूटोरियल। ओके
सर, ऑसिलेशंस वाला का भी थोड़ा सा क्वेश्चन सर अपलोड कर देते हैं।
हाँ मैं वो अलग से, तुम लोग का तो ट्यूटोरियल में कुछ डिस्कशन तो हो रहा है ना
सर? तो फिर नहीं हो पा रहा है।
Okay, so I will also give you some other problems related to action oscillation so that you can do.
Okay.
I will try to do it today itself and let's see.
Okay, sir.
Okay.
Thank you, sir.
I will stop it here. Okay, fine.
Bye, sir.
Bye sir.
Bye.
बाय सर।
Bye sir.
Bye.